Hey people, welcome back. Today I'm talking about overclocking in general, but more specifically CPU overclocking. How I want to go about this today is talk about requirements, tools, and if this is at all to your benefit. If your computer is used for gaming, numbers crunching, or editing, overclocking is to your benefit. If not, then don't expect benefits at all. If you're on a laptop, then don't do this and wait for the next video I'm planning about undervolting. Although overclocking is theoretically possible on 3 of your computer components, namely your CPU as the brain of the computer, the GPU as the middleman between your PC and monitor, and the RAM as the short-term memory of your computer. The fourth case being your monitor, that often doesn't work. How this all works is to increase the times per second at which your component does what it's supposed to. But never forget that nothing in this world is free, and strictly speaking, overclocking isn't either. It increases power consumption of the component you overclock. Inadvertently with higher power, heat output increases as well. If your computer happens to be a laptop, don't do it. The requirements for overclocking, on the other hand, are easier to qualify. At least your CPU and motherboard have to be able to do it. That's easy. If you're still rocking an Intel processor, make sure the name of your CPU carries a K at the end, and your motherboard has a chipset whose name should start with Z. The small program named CPU-Z can tell you both. Best practice also calls for a quick Google search. If you are going with times and going AMD, then 9 out of 10 times you can overclock. All new Ryzen CPUs have an unlocked multiplier and can be overclocked. Motherboard's chipset should start with B or X. When these requirements are met, you could start if you like. But remember I said heat output increases? Well, that's by chance a limiting factor at your overclocking success. So make sure temps are under control with a beefy air cooler or water cooler. Generally 90 degrees Celsius is a point at which most CPUs stop and shut down the PC or clock down. Newer Intel CPUs have their limit at 100 degrees Celsius, and that will be from the 8th gen and higher. At the end of the video, we will determine if our chips are Silicon Lottery winners or losers, as not every chip is made equally. A Ryzen 5 3600 may be called 3600 as the next, but contain less manufacturing errors within the tolerances, therefore allow better clocks, and that is what we call winners. Same with Intel's next best competitor, the i9-9900K. All may do 5 GHz, but not all do 5.2. We are talking about the same clock speeds across all cores, not a single one. So let's start the overclock. To the left we have Ryzen Master. It's AMD provided software to allow you to overclock outside of your BIOS, so directly in Windows. And to the right we have Hardware Monitor. It shows you things like temperatures, voltages, power consumption, and clock speed. We will be using these two programs to see what's going on in the system and how we can tweak it to have better performance. We go to Profile 1 or 2. Profile 1 and 2 are profiles that you can customize yourself. In there you have the control modes. Default is stock mode. Precision boost to overdrive means that you allow your processor to draw more power and inadvertently produce more heat. Auto overclock, never use it. And manual overclock, that's where we are headed. So under manual overclock we see core selection, voltage control. Third program in the list is Cinebench R20. It's found in the Windows Store. Cinebench R20 will provide us with a baseline of performance and will be our first bastion of stability test. Once we have an overview of the programs we had run on Cinebench, look what score it gives us. While that's going on, we can take a peek at Hardware Monitor. It shows us that the core voltage is hovering around 1.3 volts. The temperature is fairly toasty. The power draw is up to 118 watts. And the core speed is at 4.1 GHz, and it's not even stable. Okay, so Cinebench has done its thing. We have our first score. This is the baseline score. Baseline score means that write this down, and until the end of the video you will then see if you have gained any performance or not. 4,445 points. It differs from CPU to CPU, of course. Look at your hardware monitor. It's at 4.35 GHz. Voltages are also crazy at 1.4 volts. This is behavior we are trying to avoid. Make sure this button here is pressed. These bars control your frequency. Then we have the voltage control. Peak core voltage means that you go for more voltage for more stability, but pay for it in thermal load, and vice versa. First step I would suggest is going to 4.1 GHz. That's a point that all Ryzen CPUs can do on an all-core basis. Then hit apply. We can see in hardware monitor the 4.1 is being applied, and once that's done we hit the Cinebench run. So Cinebench in this case is, as said already, used for stability tests and for performance tests. We see if the performance is increased and we see if the chip is stable at the set frequency. 4.1 isn't a problem on no chip. 4.2 should be possible with every chip, and 4.3, 4.4, that's the points where the CPUs differ. If you got 4.3, everything's fine. If you got 4.4, congrats. Just remember to check every time you let your Cinebench run. Check the temperatures, check the voltages, see that everything is running fine. So approaching the end, as you can see, my chip does 4.4 GHz. At 4.4 we gained around about 400 points in Cinebench. That's like 8 to 10% performance increase. What's interesting about this is that AMD announces new CPUs at the moment, the XT series, that boasts a performance increase over the normal 3rd gen of 5%, and we just increased the performance of our chips by 8%. Last but not least, don't forget that Cinebench is only the first barrier to stability tests. The next step would be to run either Prime 95 or AIDA64. Prime 95 is a free software, you can just download it, use it one time and forget it. And AIDA64 is a paid version. Depending on the workloads you are expecting from your PC, let either AIDA or Prime 95 run for the same time. So if your normal workload would be a high stress situation for your PC for 2 hours, then let Prime 95 or AIDA64 test your stability for exactly those 2 hours. If you're thinking your PC will be running like 24 hours, and test for 24 hours. On that note, leave a like, leave a comment on what you want to hear next, and subscribe. Bye bye.